Good morning and welcome to Advent of Code in F#, day 12. Now, before we dive into today's puzzle, I wanted to quickly recap yesterday, or have an additional point on yesterday's puzzle. So yesterday was the cellular automata / game of life thing, and I used, for like representing the grid or the map, I used a map or a lookup table, and that resulted in like us having time to go for a walk or grab a coffee when we ran our algorithm for the input, for the actual large input. So it took us 32 seconds, and that's pretty slow. It's not the end of the world, but that was pretty slow. So yesterday I was noodling around with, could we speed this up by changing the underlying data structure? And it turns out you can. So for example, I used is this part 2? Yes, this is part 2. So I used the two-dimensional array instead of a map. And little changes actually. So if you parse it, instead of returning a map, we return a two-dimensional array. And instead of accessing the map by the keys, you have to do a bit more work, but that all works nicely. And like the big benefit is, if you look at here, if you run the code for the input, oh yeah, that's actually a cool little trick. There's a time directive you see here. If you run it in an F# interactive, let me do that. It'll say like timing is now on. So what does this do? If I now run whatever, if I call this function to calculate my final state, let's go. You'll see it actually does the work, but you'll see also that it prints out something, and this is like the time it took. So it took like 1.5 seconds. So this is really cool if you want to see if your performance optimizations or things that you think might improve performance, if they actually have any effect. And in this case, yes, they do, because now it only takes a couple of seconds instead of half a minute. So it's not the best performance measurement thing out there, but like for solving Advent of Code puzzles and having a general idea of whether you're moving in a better direction, this directive is really handy. Anyhow, that's all I wanted to share about yesterday's puzzle. Let's go to number 12. Number 12 is what's happening. 13 is like going back. That's a worry for tomorrow. Let's look at 12. Rain risk. Is it like a play on Risk of Rain, the video game? We'll see. Our ferry made decent progress towards the island, but the storm came in faster than anyone expected. We're still traveling, oh boy. The ferry needs to take evasive actions. Okay. Navigation computer seems to be malfunctioning. Rather than give a route directly to safety, it produced extremely circuitous instructions. That's not very helpful for a navigation computer. The captain uses the broadcast system to ask if anyone can help. Is this like a hidden tip? PA system, no, it's just a link to what a PA system means. Okay. So our navigation instructions, which is our puzzle input, consists of a sequence of single character actions paired with integer values. So we have an action and a value again. Oh, please no int codes anymore. After staring at them for a few minutes, you work out what they probably mean. So we have, probably sounds like we could misinterpret this and have a part 2. Anyhow, N means move north. East, southwest, yes, and all by a given value. Yeah, could be. And then you have L, R, and F, left, right, and forward by degrees. Interesting. So this is turning, not moving left. Turning left, turning right, and moving forward. Ship starts by facing east. Only the L and R, the actions, change the direction. Yeah, so only turning changes direction. If the ship is facing east and the next instruction is N north 10, the ship would move north 10 units, that makes sense, but will still face east. Whoa, this is like a super cool ship that can move sideways and backwards and whatever. Okay, that seems clear. Let's take a quick gander at the example. So if we start facing east, then we get forward 10. We just move east 10 units, yes. Then 3 north, but we keep facing east. So F7 would go 7 to the east, yes. Then we rotate 90 degrees. Is it 90 degrees clockwise? Yes, it's 90 degrees clockwise. Could it be negative? We'll find out soon. F11 would move the ship 12 units north because... Oh. Wait, so we rotate 90 degrees and then we face south. What's happening here? So we're east 17, north 3, and then we move forward when we're facing south. Oh yeah, you can't go north, negative north, you just go south. So 3 minus 11 is minus 8, which is basically south. I'm not sure if we should use like XY coordinates. That'll probably make more sense but be a bit confusing. But otherwise we have to like flip from north to south. Yeah, let's just use a compass as our grid. What am I trying to explain? So we have our, what's this called? I don't know. But let's use this for east. If we're in the negative space, we're west, north, and south. And yeah, so origin is origin. And if we're like on the y-axis, -1, that's actually like south 1. -1 is like west 1. So let's take east-west, the x-axis, north-south, the y-axis. That'll work out. It'll be a bit of mental gymnastics mapping these things to xy. But otherwise we'll be confusing ourselves with like -4 east. What is that again? Is it west? So let's keep it in the xy world. Cool. So we have our grid. And at the end, look at how far we are from our original position by using Manhattan distance. And the Manhattan distance is like sum of the x vector and the y vector. So if we're 17 east, south 8, that's like just the sum of those two. Okay. So we run our puzzle input instructions and then we look where we end up. Yes. Let's grab our input. And maybe quickly look at it because the rotation was 90 degrees in the example. Well, what can the rotation be? I see 270, I see 180. It's like those three. Let's parse it and figure it out. So parsing it is pretty simple. There we go. Parsing it is pretty simple because it's always the same format, one character and then just a number. So we can use a basic string, substring, parse things to a number kind of thing. So let's parse the text by mapping over every line, and for that we need lines, which we do, yes. And every line is a command or an instruction. Let's provide types for these instructions. What's the correct term? Instructions, yes, navigation instructions. So type for all the kinds of instructions. North, I'm going to use an option type again. because it represents a choice between all the different commands or instructions, sorry. And it's always north number, south number, right number. Yeah, let's call this action, actually, action. So north, east, south, west, left, right, forward. So these are all the possible actions we can take. North, south, east, west, left, right, forward, yes. And then an instruction is nothing but a... let's make a record type just for clarity. We have an action and a value. Yeah, let's call it value, which is a small number. Yeah, it's an integer. I think we'll be able to parse everything. Yes, they're all pretty small steps. So let's parse a line. So we would like to end up with an instruction. For that we need an action and a value. So action and the rest. So I'm just destructuring the input string. Wait, a string is a sequence. Let's do it differently. So let's do let action is match line. L is a very confusing character, so let's write it out in full. Actually, let's to list the line. So now it's a list and that's a bit more easy. So action is the first character. And it can be any of our actions. So let's just copy paste this. And let's put a character, make it characters. Should not have done that. Can I like copy paste for multiple lines? Now I'm trying something I never did. Oh, it works. That's crazy. There we go. So this is a parser for our actions. And let's handle the unknown case. Percentage, sure. This is our action, and let's parse the value as well, which is everything but the first character. So anything but the first character is basically line 1 and up, and parse that into an integer, and then we can return an instruction with action or action and value or value. What's it not liking? What? The operator expression. So this indexing is used on an object of indeterminate type. Yeah, that's true, but let's provide an example. No, let's not provide an example. Let's just say text is a sequence of strings. Probably it'll figure it out then. No. We don't call parse line. Yes, we do. I am confused as to why it's not figuring out the types itself. If I call parse input, can it figure it out then? No. What's happening? Yes, I should use my list representation. Okay, let's do it this way. Oh yes, okay, I'm confusing myself by nesting those two functions. Good going, good going. So actually it's complaining about this inner function. There we go, sec map parse line, but let's first do a sec to list of the line. There we go, that's better. No, it's not changing anything. Okay, so this is a line is basically a string. Let's do it this way again. I'm sorry for this. I'm like getting lost in a type world. What's it saying? Oh yeah, if you want to do string interpolation, it's this. If you want to use this, what's it called? I forgot. But forget this even exists. Let's use the new way of doing string stuff in F#5. There we go. Okay, so this was a roundabout way, but I think we can finally parse our input. Let's go. There we go. Let's take a look at what we have. So our first instruction should be left 90. Left 90, yes. The next one should be forward 67. Yes. Do we have negative numbers? No, we don't. I'm just going to quickly look at all the possible rotations we can have. So I'm going to look up all the rotations. So left or right. Oh yeah, it's difficult to match. No, it's not difficult to match. So you can match on lefts like this. And let's pull out the values. And let's see how many different we have. 90, 180, 270, yes. And for the rights, probably the same. Yes, okay. So we can only rotate into 3 different directions. There's no negative numbers or no, let's do a 360 donut spin. Cool. So we have a fixed set of instructions our vessel should take, and it's just like going one after the other. There's no moving back to previous instructions. So this is a textbook example for a fold. So the fold will go over every instruction and update like the current position and the rotation or the direction the ship is facing. Yeah. So if you use a fold, you need a folding function and you need a state. So let's think about what the state is we want to keep track of. And if you look at what we're being asked to do is figure out where we lead to. So we kind of need to know our current position and more, because the left, right, forward is like changing orientation. Like I'm facing north, I'm facing east. This is also a thing we need to keep track of. We start facing east in the origin location. Yeah, let's call our starting point the origin, like 0, 0. This is where we start. So the state we need to keep track of, I'm just gonna call it state for lack of a better term, is the current location. Let's just represent that as an XY pair. Like this is our grid. East means, yeah, we already went over that. And orientation is like which way are we facing, and we can turn with degrees. Should we just, no, let's not make it harder than it needs to be. Let's introduce a new union type. Orientation is we're facing southeast. Yeah, so it's the coordinate. What's the bird for like the directions on a compass. I'm blanking out, but that's what we need again. So let's just make it a second union type. And there we go. So we basically already have north, east, south, west somewhere. I'm gonna put my types together. We basically have it already here, but I'm like not tempted to combine these into one single, because they represent different things. This is like an action our ship can take, and this is which way is our ship looking. So it'll be confusing if we try to like inline this or like reuse the orientation as part of the actions. It's not worth it. I'm a bit confused also because I see like it's north, east, south, west. It's like graying it out. This value is unused. But left, right, forward, it's not saying, no, something's wrong. Something's wrong. Oh yeah, now it's confusing because I do not specify my types explicitly. Now it's confusing like orientation with action in here. So let's type action. Yeah, why can't you figure out that this is like action.n? Okay, that's too bad, but let's just preface every action. There we go. So this is our state, our initial state. Let's also declare that is a location starting at center of the map, and our orientation is facing east. You know what, I'm gonna fix it in a different way. Then it's also more clear what which of the two things we're referencing in our code. There we go. So let's get rid of this preface again. There we go. So this is the initial state. Let's load everything into the REPL because I renamed a lot of things. Okay. So we have our initial state. There we go. Let's run an instruction over it. So first instruction is, where did you go? There you go, left 90. Should we just implement that instruction? Yeah, sure. So let's call this, what are we going to call our folding function? What do you do with an instruction? We execute it? Sure. Execute given a state and an instruction, and it should return a new state. So I'm thinking ahead here. I'm like, actually, let's do it the other way around. Let run instructions is. That'll be more clear then. So for every instruction, let's fold over something using our execute function. So this is the folding function, and we provided an initial state. There we go. And then this becomes the thing I was trying to define. And execute is something that takes a state and an instruction, and it should return a state. There we go. Let's put all the like example and input handling at the end. Yeah, and let's just call it for our input so we can see what's happening. So this is not doing anything, it's just like threading the initial instruction through the entire instruction set, or the list of instructions. But now we can do a step-by-step implementation of all the different instructions. And the first one is actually one of the, is it a trickier one? It's not tricky, but it's like we have to rotate the ship. Is rotation the correct word? We have to change the orientation. So let's have this execute thing. Yeah, let's keep it in this function for now. Let's see where we end up. So let's pattern match on the instruction, yes. Hello. Okay, my computer was freezing up, and let's not just match on the instruction, but actually let's match on the action of the instruction. If it's left, do something. Otherwise, let's not do anything otherwise. We'll just crash if we don't know the instruction. Bad practice, people, but when you're test driving or when you're implementing, it's nice to take small steps. So, left. Means we have to change our ship's orientation. Am I already regretting the way I represent orientation? Nah. Let's see. How do we rotate? So actually what we need to return here is the state with orientation. Something else. Let's call it rotate. I don't know what we're gonna do here, so I'm just gonna write a function placeholder. So rotate left, and what are we rotating? Given our current state and the value of our instruction. There we go. I think I'm gonna clean this up in a second, but let's go with this for a while. Does it make sense to pass in the state, or just like the state dot orientation? Let's do it like that. There we go, there we go, there we go. Everything compiles, everything compiles. So rotating left. So we are now facing this way, and we know we're rotating left, and we know like the degrees. Should we just do an exhaustive pattern match? For my brain is like locking up, so yes, let's do an exhaustive pattern match. So let's match on every possible combination of orientation and value. Bad idea, that's a lot of combinations. Yeah, okay, but anyhow. So orientation is, for example, north, value can be 90, 180 or 270. Let's keep like writing our function from every combination until we see the pattern emerge. So if we're facing north and we have to rotate 90 degrees clockwise, was it clockwise? Where are we rotating? Right? Right, 90. Oh yeah, the clockwise counterclockwise thing is in the R or the L. So rotating 90 degrees to the left is like doing chop. Yeah, I don't know. My webcam is like showing me the mirror image. So basically, when you rotate north 90 degrees, when you're facing north and you rotate left 90 degrees, you're facing west. Or if you look at the example, right 90, okay, we're not doing right. Yes. 180, facing north should be south. Oh dear, this is a very exhaustive pattern, or a very long pattern match. It's like 12 matches. It's 12 matches, and that's only for left. Yeah, okay. If you're north, then you go 270 degrees east. Yeah. So these are the north rotate left things. And when I'm looking at this, let's keep it an exhaustive pattern match, because it's you kind of have to do that if you're mapping from a union type to another union type. But instead of hard coding the direction we want to rotate into the function name, let's provide it as a as an input. So this is an action. That's now we're actually the you can rotate left and right. Should we also? Yeah, let's also make a option type for that. Do we need to? No. But yeah, we're going down the type route today. So rotate left. And this takes a rotation. Let's call orientation current orientation. Or rotation is a bad word. What's left or right? How do we call that? I don't know. But I'm getting lost in the details here. Let's just keep moving ahead for a while. So what am I trying to do? I'm trying to make one rotate function that takes whether it's left or right, what orientation are we facing right now, and by how much. So this is for left and north. This is for, oh dear, it's going to be a long pattern match. Let's do the right part, sure. So if you rotate 90 degrees right, it should be east. If you rotate 180 degrees is actually an easy case, right? It's always like the opposite. And 270 is a flip. I'm doubting, like, should I go all the way, or am I, because I don't like it already? Because basically to exhaustively test this, we need to write a test for every case, because it's very easy to, whoops, type a typo here, and then we have a bug, and it's going to be really tricky to find that bug unless we execute just that single pattern match. Because this is only 1/4 of all the matches. Anyhow, I chose this path, I shall follow it. So, east. What's east looking like? If we are facing east already and when we rotate 90 degrees left, it's north. And this should be west. Actually, let's do a shortcut. All those 180 degrees are pretty easy. Doesn't matter which direction we go. It doesn't matter, no. Whenever we have to rotate by 180 degrees, it's like just change. Flip to the other side. So east is... Sorry. So northeast should turn into west. South should turn into north. And west should turn into east. So now it's a bit better. The 180s can go. There we go. So these are all the possible 180s. Doesn't matter where left or right. Yes. Left, north is west. That's still correct. Yes. Left, north, and 270 is basically right, north. 90, yes. Right, north, 90, east, west. Yes. Okay, we're good. So left, east is north. Yes. Left, east, 270 is south. Right, east, 90 is south. And right, east, 270 is north. So this was north, east. Let's do south and west quickly. Or quickly. We passed the quick point. South. If we're facing south, and we turn left 90 degrees, it's east. Facing south, and we turn right 90 degrees, it's west. If we're facing south and we turn right 90 degrees, it's also west. Okay, this should probably be east, south, right. It's getting hard on my brain. So north, east, south, and west now. This is the biggest pattern match I have written in my life. So much room for error. So facing west, we do left 90, south, left, west, that's north, right, west, north, and that should be south. This is a big old pattern match, and probably the squigglies should go. The squigglies are not going. Oh, shuck. Because I'm using an integer, I cannot exhaustively pattern match. Yeah, because I'm using an integer, it's like saying, no, no, no. You shall not exhaustively pattern match. So let's write a guard clause. The guard clause will get executed every time. Maybe let's put it at the bottom. So whatever we get, but if the number is not in can I do this? Is this like exhaustive? Will it figure it out? I don't think it will figure it out. So this is not an exhaustive pattern match anymore. Now I'm curious, if I do this, like it's matching on whatever, but I'm placing a guard here, does the pattern matching recognize it? However, a pattern rule with a when might successfully catch, so that's what we're doing, but the compiler cannot help us with this. Yeah. So I'm kind of coming back to my decision to model it like this. It's really bug prone, and it's not even matching exhaustively, so it's just like a really big lookup table right now to do the rotation. But gedane zaken nemen geen keer, as they say in Dutch, or something like that. We went down this path, let's follow it through. Let's follow it through to conclusion. So now we should be able to run the first instruction. Yep, match cases are incomplete because we are crashing on the second part probably. So we're crashing on line 58. 58. Oh yeah, that's this match. So we handled the L case. Let's just put some scaffolding in place so we can more clearly see what's going on. Come on. No. There we go. Unknown action. Let's print the entire instruction. And let's print the state as well. So this is again debug driven, but we're not like trying to find a bug here. We're just like gradually building our algorithm. This is like just to have a printed output. This is our to-do list. Now it's saying, hey dear friend, you're stuck somewhere. No, it's... Where is it breaking now? Part 1, line 58. How can it... This is an exhaustive pattern match. Is it breaking here? Then I would expect my error to be on line whatever. maybe I didn't copy paste all the new function definitions into the REPL. Let's try that again. Yeah, okay, this is what I was expecting. So we can do the rotate left thing. And now we're looking at forward move. So we're trying to move forward by 67 spaces. We already rotated north because of the left command. Yeah, that makes sense. So let's implement the forward right now. If we hit a forward kind of needs to take the current orientation into account, right? Yes, it does. This is the only action that takes the orientation into account. So let's extract it into a function again. What changes? State. The orientation changes. Doesn't change. It's the location that changes. What do we need to move forward? Just the entire state. We need to know where we are, and we need to know which way we're facing, and we need to know how far. It's a bit weird to like rip open state sometimes and don't rip open the state in other cases. Yeah, so if I were writing cleaner, non-hacky experiment stuff, I would probably make sure all these signatures kind of look consistent, because now it's a bit confusing. But anyhow, forward takes a state, and the value, well, value is such a generic term, but let's call it that. And you know what? Never mind. Let's just return a new state. And maybe let's change rotate so it also returns a new state, because it's getting confusing in here. This should be a simple dispatch of action to the handler for that action, basically. Because right now it's a garbled mess. Okay, but let's first implement forward. We're doing one step at a time here. Forward just looks at which way are we facing. Yeah, and we move that many steps in that direction. So let's pattern match again. What were the possible orientations? These are the orientations? Yes, they are. If we're facing north, back to our grid drawing, if we're facing north, our Y component should increase. Let's rip out X and Y. And the new X and Y X and Y should be whatever. Let's figure it out later. And then what we return from here is the state with location, the new location. So this is what I want to have my function look like. We get a current state, we say, okay, we have to move forward. We do the moving forward and we return the new state. Yeah, makes sense. So if we're moving north, we increase our Y coordinate. Yes. So it's actually X and Y plus the value in the instruction. Yep. Let's do the same for east, south, and west. south is just the opposite, so we are decreasing. If we're here and we go south too, it's like womp womp. Yep. That means that y grows. That's different than the other days. So let's draw that in big red, so I don't get confused. Increasing y means going up. Increasing x means going right. So increasing y means going up, means going north. Yes. For east we are increasing x, and for west we are decreasing x. Does this look correct? Plus plus for the positive. Yep. Minus minus for the negative. Yep. South is on the y-axis, west is on the x-axis. Yes. I think this is our forward thing. Too bad. No, that's the only one that uses it. Okay, yeah. So this is okay. Now that I'm looking at it, it should work, and we should go to, what are we trying to do? Forward 67. So forward 67 when we are facing north should push us up on the y-axis, so it should end up at 0.67 facing north. Let's try it. We are at 0.67 facing north, and we have a right which we have not implemented yet, and we won't be doing it just now because I don't like the, as I said, I don't like that this looks different than this. So let's make this look more similar. Yes. What should this look like in a more similar fashion? Just gonna put it under there so we can see what's going on. So we kind of need something called rotate left given a state and the instruction dot value. Yeah, let's not push in the entire. So what's the difference? Rotate left state instruction. So we have to grab the orientation and return the entire state. So let's comment this out, or let's just remove this line. So we take, for rotate, we take the orientation. Gone. I'm just going to copy paste the call quickly so we can see what we have to do. So the rotation is still the same, state instead of current orientation, and the value, yeah. And so this is state dot orientation. There we go. So this should kind of line up, and we need to return the new state. So this is the new orientation. This huge pattern match. And let's return state with orientation, the new orientation. There we go. So now our functions look the same. This is much better. Our functions look the same. We are same-ish. We always pipe in a state, and the function name has like the instruction action, and we provide the value. Cool. So now we had a next action failing being right, but I think we were a bit speculative and implemented right already. If we do this, what happens if we rotate right 270? So we rotate left 90, so that is facing west. Let's give it a go. Facing west at the same location, so let's remember that location. Come on. Facing west at the same location. Yes. Everything is going good. Now we need to move west. Yes. So we have rotate, rotate left, right, and forward. Now we need like the 4 cardinal direction movements. And let's start with west arbitrarily, because that's the first input I see in my example input, or my input. So go, go. Let's write a move function. What's west actually? We use it for rotating, but let's also use it for this. Is this a smart move? Yeah, doesn't make that much difference. So, yeah, this will work. So, if we want to move into a certain orientation, let's again pattern match. This is the day I do pattern matching until my fingers bleed, I think. Moving west. Actually, what does moving do? It does not change the ship's orientation, it only changes the ship's location. So it will be something like this, and when we return the state with the updated location. And west means going back on the x-axis. So it's, let's extract the xy coordinate again. Yes, so going west means decreasing the x coordinate with the value and keeping the y coordinate. And it's the same for east, except we increase. For north, it's north. Yeah, let's take a look again because I'll get confused otherwise. It's increasing the y, and south is decreasing the y. There we go. I think this might be implementing move. I hope it works from the first try, because debugging this, or it's pretty easy if we like test every handling function or every different function we call here, but I'm dreading like testing this. If there's a bug in this one, in the rotate, that won't be fun. No, that won't be fun. Maybe it's a good example. Maybe that's a good case to do some property-based testing, but let's tackle that one when we get there. Huh. I was thinking we're done. Oh yeah, we need to delegate to the move function. So we are almost done, except that we are not forwarding east, south, and north to the move function. So let's do that first. So when we hit an N, we should move north. Yes, if we hit an E, we should move east. And if we hit a S, we should move south. It's 100 lines of code today. It's not the most concise solution, but we're not going for concise here. And we are matching exhaustively. There's no unknown commands anymore. Awesome. So the only thing I dislike is this huge match, and especially, I wouldn't mind the huge match, but especially like this green squiggly line, I'd rather not. And I think it's actually doable if we just parse our input commands or our instructions a bit differently, because we know, our assumption was if we are using a rotation, it can be only one of three, like 180, 90, or 270. We could have made this exhaustively by just not using an integer value. But this is the path we chose. We end up somewhere, which is already good. Let's keep track of our final location or our final state. And now we need to Manhattan distance. Yes, so we are 1000 west, 24 north. No, yeah, 24 north. Doesn't really matter, we just need to sum up the absolute values. And I'm not even gonna code that, I'm just gonna REPL it. There we go. We have a number after a struggle of, I don't know how long, almost an hour. You win some, you lose some. Please, please, please. Oh, thank God. No mistakes were made, or at least no bugs were introduced. Part 2. So let's call the shop. What will change? I'm thinking we are misinterpreting the instructions and we need to do something else. Let's see. Before we can give the destination to the captain, we realized that the actual action meanings were printed on the back of the instructions. There we go. Almost all of the actions indicate how to move a waypoint, which is relative to the ship's position. So we're not moving the ship, the instructions, they're moving a waypoint. Oh, my brain. So N means move the waypoint north. So that kind of means move the ship south. Is that what we're aiming at? So yeah, okay, these make sense, but action L means to rotate the waypoint around the ship left counterclockwise given the given number of degrees. I cannot make sense of this sentence. I need examples. So left right is rotating the waypoint around the ship. Yeah, I need examples. And F means to move forward to the waypoint a number of times equal to the... This is just... Yeah, examples would be handy. The waypoint starts 10 units east and 1 unit north relative to the ship. Okay, so we have extra state we need to keep track of. Yes, we need to keep extra state, which is the waypoint location. What? The waypoint is relative to the ship. If the ship moves, the waypoint moves with it. So it's like a drone. We have a drone that's following us. Yes, in my mind, this will be a drone. So the same instruction set as above. Okay, F10 moves the ship to the waypoint 10 times. Forward 10, let's read the forward explanation again. Move forward to the waypoint. Let's draw it out. We start here and our waypoint starts at 10 east, 1 north. 10 east, 1 north. So forget scale, but the waypoint is a different color. Waypoints, drones are blue. My drones are blue. So 10 east, 1 north. The waypoint is somewhere up there. And it moves the ship to the waypoint 10 times. Okay, so it's not a step of 10, size 10, it's like move 10 times. Oh no, okay, yeah. Move forward to the waypoint a number of times equal to the given value. So our waypoint is at like 10-1, and then we get forward 10. This means do the forward movement 10 times, and the forward movement is moving the distance of the waypoint, the distance between the ship and the waypoint, which is 10-1. So F10 in the example should move us to east 100, north 10. Oh my god, we're taking big steps in all of a sudden. And the waypoint stays 10 units east and 1 unit north of the ship. Okay, so this drone that's hovering above us, it's like a vector. And if we rotate the vector, it's kind of impacting how our forward movement will change. Okay, it's starting to make sense. And so these are rotations of the waypoints around the ship. So we're left and right is moving the waypoint. Forward means move into the direction of the waypoint vector. And all the other ones mean move the waypoint itself. Okay, it's starting to make sense. So F7, nope, N3, that's what we're looking at. move the waypoint 3 units north. So we're at, the waypoint is at 10, 1. No, it's of a difference of 10, 1 to us. Yes, so then the 10 of 1 relative to us becomes 10 and 4 relative to us because we move north up 3, yes. So instead of the absolute location of the waypoint, maybe it makes more sense to keep like the relative position according of the relative position of the waypoint when looking at it from the ship. So it's always, for the waypoint, the ship is always like the origin, it's always 0, 0. So forward 7 again is like doing 7 times the 10 east and 4 times the 7 times the 4 north. Yes. This again moves the ship, yeah, and the waypoint stays at the same like relative position of the ship, yeah. Rotation, that's also interesting. It's the first time we see it. What does rotation mean? Rotate the waypoint around the ship clockwise. 90 degrees. So what's happening? The waypoint is currently at 10, 4, and then we have to rotate the waypoint 90 degrees clockwise. So rotate it to the right. So instead of 10 units to the east and 4 units to the north, it becomes... This is tricky. My brain is not grasping what this is saying, so I think we need to draw this out. Or I need to draw this out in order to understand what's going on. Let's grab some new piece of empty canvas. There we go. So let's say we are red. Let's say we are here and our waypoint is at 10 to the east, so 1, 2, 3, 4, 5, 6, 7, 8, 10, and 4 to the north. 10 and 4 to the north. So our waypoint is here, and then we need to rotate the waypoint 90 degrees clockwise, and that suddenly ends up 4 to the east and 10 to the south. So that kind of moves our waypoint there. So yeah, that's actually rotating 90 degrees. Let's draw a rotating 90 degrees clockwise arrow. But what does this mean in coordinates? Let's draw the grid. So this is the X and this is the Y. What does this mean? Rotating 90. So this is X, this is Y. I forgot everything about like rotation calculations and stuff. I remember there's a lot of matrix calculations involved. Let's not do that here. We've been using exhaustive pattern matching, so let's go all the way today. So we are here at x0, no, sorry, we are here at x10, y4, and suddenly we are at y minus 10, so it's flipping the sign of the x-coordinate and changing x and y. Yeah, I'm gonna need to do this on a case-by-case basis, like for every position in the quadrant. Oh no, this is going to be... I think this is the exercise that is going to break me. Or at least I'm going to need a little break before I dive into these kind of calculations. Then we just move towards the waypoint. So I'm just gonna finish the example. Yes, that all makes sense. And then we just need to calculate the Manhattan distance again. So what changes from part 1? Our movement does not move the ship, but it moves the waypoint. Our rotation does not rotate the ship, but it rotates the waypoint. Our ship doesn't even have a orientation anymore, or it doesn't need one. And forward doesn't move the ship. Yes, it does move the ship forward in the direction of the waypoint. So basically everything changes. Yeah, I'm going to take a little break here and we'll take it from there. So I hope you enjoyed my part 1, brute forcing my way through all the possible options, and I'll see you soon for part 2. Bye.